Hi, I'm Alice Egan, and welcome to SaaS Savvy, your online resource for breaking into and succeeding in the tech industry. In this three-part video series, I'll be explaining the fundamentals of application programming interfaces, or APIs. If you are not a software developer, or you are at the start of your quest to become more technically literate, then this video is for you. I'll be explaining pure concepts, no coding required. SaaS Savvy provides curated content aimed at non-developer tech professionals seeking to uplevel their technical aptitude and industry know-how. So follow, like, and subscribe for content that brings SaaS and cloud technologies back down to earth so that you can sell, market, consult, and design more confidently. An API is a software component that enables two otherwise unrelated pieces of software to communicate with each other. And that's the definition. But as a sales engineer or solutions consultant for a software as a service company, memorizing this definition only ever got me so far. I may have a liberal arts degree and no background in software development, but I've always found myself in technical roles within the SaaS industry. APIs came up constantly, and I had to explain technical solutions to customers all the time that always involved APIs. They're open, or we're an API first company, I would say. But truthfully, for a long time, I struggled to really get what APIs were and what I actually meant by any of my responses. And this makes sense because the great thing is APIs are everywhere. They're the backbone of basically every digital experience we have. As I can personally attest, you can respond to a million questions with, you can do that via the API, and people will nod their heads and take you seriously. But the not so great thing is that because APIs are everywhere and because what's considered an API is so broad and often contextual, it can be very confusing to truly understand what APIs are and how they work. In my quest to answer the question, what's an API, I have personally found the following. So on one hand, people abstract the definition so much or get super caught up in analogies that it's not always very clear how it actually works. And on the other hand, people use too many technical terms in the definition where it falls flat if you're not a programmer and you don't know what a subroutine is. And then finally, people use the term API interchangeably for many kinds of APIs, but 9 times out of 10, they're referring specifically to REST APIs. And this kind of API has quietly taken over the term in general. So you can think of REST APIs kind of like the Xerox or the Kleenex of the API world. Plus, the word interface is undoubtedly key to understanding what an application programming interface is. And I'm a very visual person, and I couldn't for the life of me visualize what an API looked like. So in this series, we are going to learn about how APIs take inputs and respond with outputs, just like the interface of, say, a microwave. I created this video series on the fundamentals of APIs for non-technical tech professionals for a few reasons. One, it's important for all of us to have a better handle on what's going on in our devices and on our screens and how all our data is making the rounds. It's not magic. Two, for tech professionals in fields like sales or success, once you understand APIs at a deeper level, beyond just they allow for integrations, you'll be able to not only better communicate the value of your flexible, open, extensible software products, but you'll really understand the entire SaaS ecosystem and economy that you're selling into and working within. Once you understand APIs, a lot of pieces of the tech puzzle start to piece themselves together. So let's go. We're going to be talking about APIs and software interfaces, remote APIs in the web, and rounding it out with REST APIs. All right, part 1. AP interfaces. In this first part of our API fundamental series, we're going to define what APIs are and the overall purpose they serve, touch on various APIs out there that are behind all our favorite apps, break down just what a software interface is, and discuss how both humans and machines use APIs to create all our digital experiences. My aim is that you finish this video with an understanding of what APIs are and why they are so important to software, and that you can confidently articulate this for your job or just for 21st century life. A heads up on some terminology. I'll be using the word programmer to describe someone who codes software and apps. In my world, programmer, coder, engineer, developer are all used interchangeably, so I'm just going to go with the one that makes the most sense. I'll also be using application and app interchangeably because application is 4 syllables long. It's a common thing to talk about applications on our computers and apps on our phone, but they're both applications and one is just easier to say. Why don't I give you the gist of APIs before we get into the dirty details? An application programming interface is a software interface used by both humans and machines that enable 2 independent pieces of software to communicate. Programmers design and use APIs to more easily write software or to integrate with other pieces of software. These APIs are also machine-readable interfaces that are used by software to talk to other software without needing to know its whole life story, i.e. its code base. Internal APIs connect the front end of an application, i.e. the graphical user interface, or GUI, to its back end, i.e. all the files of code on physical infrastructure like servers that dictate what an application does. Remote web APIs use the web to allow 2 independent pieces of software to share data or integrate by granting each other access to specific data that live on each other's backends. And every tap, click, and swipe that we humans make on all of our devices trigger API calls to the backend that make our apps do what they're programmed to do. But these API calls are all hidden from us behind our graphical user interfaces, GUIs or UIs. Basically, some APIs make software work, and other APIs allow for the sharing of data to other computing machines or software applications. In the business-to-business software as a service, aka the B2B SaaS world, APIs open products up for integration and innovation, and this drives what's been dubbed the API economy for businesses. And that is the gist of APIs. But stay with me. Let's get into the details now by really defining APIs. So we'll start here. Anytime 2 independent pieces of software or hardware need to communicate, there is some sort of interface helping them do so because they likely are not programmed in the same language. Whether we are talking about the hardware of your mobile device communicating with software applications installed on it, the front end of an app communicating with the back end, or 2 separate software applications like Google Calendar and Zoom communicating to get your virtual meeting on the calendar, APIs take many shapes and forms. Think about this. What do these 3 things have in common? You allow Instagram to access your phone's camera. You call a function in JavaScript to sort a bunch of numbers in your code. Or you copy-paste some text on Google Docs. All of these use an API to communicate and exchange data. More specifically, we see an operating system API, a programming interface, and a browser API in action. To revisit our definition from before, an API is a software component that enables 2 otherwise unrelated pieces of software to communicate with each other. It consists of standardized rules and functions that determine what data may be taken from or modified within an application, and it includes a software interface that is written to support those technical specifications. And in just a little bit, we're going to get into what a software interface is. Let's look at a few more examples. You click the post button on Trustpilot to submit a review. You stream a song on Spotify to your smartphone, and the customer support software Zendesk syncs with related customer data in Salesforce CRM. Now, these also use APIs to do what they do, but these APIs work via the web. More specifically, these 3 actions use remote web APIs. Remote, since the resources, reviews, songs, customer data, are located outside of the software application or device that is calling on them, and web, since the APIs are accessed, well, on the web. And even more specifically, these all use web-based REST APIs to communicate and exchange data between the 2 systems. To get a better understanding of all the various kinds of APIs at play across our digital lives, I'm going to tell the story of a hot new photo sharing app that should give you some more context. This is Photolly, the newest competitor to Instagram. It does the exact same thing, except without all the bullshit ads and algorithmic finagling of minds and souls. And just like all the other apps on web or mobile that we use all day long, it wouldn't exist without APIs. If there's one concept I want you to take away from this video, it's this. All the apps that we use every day boil down to a bunch of APIs on an application's backend with a pretty interface sitting on top of them, i.e. our front-end user interface. An application's backend at a very high level consists of a server, a file system, and a database for collecting all the data from the app. And Photolly looks no different. Programmers often start building applications by building APIs for all the things that users are going to do in their apps. For example, Photolly started with a bunch of APIs for taking, filtering, posting, and sharing photos. These APIs and the logic for how and when they get used is the Photolly app's backend. The Photolly programmers also designed a front end for us end users to use so that we don't have to call these APIs to take and post photos. We use the front-end GUI instead, and this abstracts from us the code and API calls that run on every click, tap, and swipe. The front-end UI is developed to take all the back-end photo data and render it nicely on our device's screens. When you click to like a photo on your front end, that triggers a like photo API call to the back-end, where this hits a server and updates a database. The Photolly programmers also made specific data and resources in Photolly available to other programmers to use with a publicly available API. Opening up Photolly to citizen developers or partner companies is how we've ended up with third-party integrations that allow us to do things like create and sell our own filters or create apps that help you automate posts. Let's say I take out my iPhone and open the Photolly app. This is the front end, what I use to interact with apps. And when I click to allow Photolly access to my iPhone camera so that I can take a photo in-app, this uses my phone's camera API. Once I take my photo and decide it needs a black and white filter, Photolly can tap into an image library embedded into the app via an image library API. And this grabs the code to take my photo from color to monotone. Finally, I click Share to upload my black and white image to my gallery, and Photolly uses a remote web API to send it to their servers in a remote data center for storage and processing. An API itself is a group of logic that takes specific inputs and puts forth specific outputs. So I need the camera, return to me the camera. I need the image code, return to me the image code. Here's my photo data, send it to the cloud. When we do something that uses an API, we say we call the API, make an API call, or make an API request, all the same thing. A call makes requests to software that sits on a server in order to perform particular actions, and a call is made up of verbs and nouns. Get the app started up, get me the image code, post my photo, delete my photo. Internal APIs facilitate communication inside an app itself. For example, we see here as Photolly's front end talks to the back end via a set of APIs. This ultimately allows the app to do what it's been programmed to do, i.e. share photos. But other kinds of APIs are designed to use the internet in order to plug one application directly into the data and services of another by granting it access to specific parts of a server where information is stored. It can then send the system's response back to the other system. This is what happens when Photolly integrates with Google, for example, so that you can log into the Photolly app with your Google credentials, which are stored on Google's side. Another example is when you integrate a customer relationship management system like HubSpot with a marketing automation software like MailChimp so that you can send the right email marketing to the right customers based on data in each other's systems. HubSpot developers don't need to know anything about MailChimp other than how to use its API to get marketing data and how to use the API in their code. They just need to talk to the interface. The fact that HubSpot developers can use MailChimp data without needing to know the entire underlying code of MailChimp is huge. It's this opening up of selected data to others that makes APIs such a big deal, especially in the SaaS industry, where being able to integrate between software applications across a business is crucial to business intelligence, automation, competition, and ultimately customer experience. Developers at one company can design an API that makes selected data available to other developers both in-house and in the outside world. Third-party developers can use this interface to build integrations or apps that extend the functionality of the product itself without needing access to the bedrock code. This is what makes an API an interface. It acts like an intermediary where you can request data from an otherwise closed-off application. The most important business takeaway for the SaaS industry in particular that I want you to walk away with is this. APIs allow a company to open up their data and resources without having to give away the keys to the car. They can choose to decide what kinds of data they want to make available for use without compromising on security and control. APIs allow SaaS products to integrate, expand their reach, bring in new streams of revenue for access to APIs, and allow for greater innovation with all of the possibilities that opening up proprietary software to the outside world can bring. But this begs the question, what's a software interface? For me, just like easily defining an API as an interface for sharing data, defining an interface as a place where systems meet and interact didn't really help me when it came to understanding what a software interface really is. As a non-developer, I found this hard to wrap my head around. Software is a bunch of code and files, so what does an interface look like? Well, we may forget that computers only understand zeros and ones, and in the early days of computing, you had to program and communicate to computers in binary code. But most humans don't fare so well with zeros and ones, so in the 50s and 60s, programming languages emerged that abstracted or made more simple the complex code that computers could understand. However, even by the 1980s, people still had to use code to talk to computers through a command line interface. But luckily, someone had the genius idea to slap a graphical user interface on top of the applications people were using on computers, and this is when the modern world of personal computers could truly emerge starting in the 80s. We no longer had to talk machine. We could click buttons on an interface, just like clicking buttons on a microwave, to talk to the computer in a much easier and more intuitive way. So a graphical user interface is to humans as an application programming interface is to the programmers who use them to code and to the software applications who use them to communicate through their code. In a GUI, we use elements on our screen to see information and also to trigger actions such as sharing a message and a photo. An API provides an interface that software can use to talk to other software through inputs and outputs of data. These functions allow other software to interact with the application that's providing the API to send or receive information or to trigger actions. Every software application out there ultimately exists of code in files written in a programming language based on the Roman alphabet. This code is stored on a host of computing machines, including things like servers and databases and routers and networking wires, i.e., its infrastructure. Here, the code gets compiled into zeros and ones so that the machine hosting it can understand it and allocate memory and processing power to making it work. In computing, that combination of software code plus the hardware infrastructure and architecture is referred to as its implementation. I, however, refer to the implementation as the whole shebang. Think of it as the source code, the entire circuitry of the application itself. And you can imagine with large-scale apps like Facebook, Meta, or big SaaS products like Netflix that this implementation is pretty wildly complex stuff. And this is why programmers design an interface on top of it all that makes it easier to use. This is very similar to a microwave. Luckily, I don't have to know the intricate details of how my microwave is wired to pop a bag of popcorn. I just use an interface of buttons and dials on the microwave that hide all the circuitry from me. I put inputs into the interface, the inside circuitry has been programmed to fire off, and I'm returned an output of a perfectly popped bag of popcorn. When building a software application, programmers know that they will need to access data and services in that implementation. This might be to make their lives easier while building out various parts of the app itself, or because they eventually want to open their app up to easily integrate with other software. So just like with a microwave, application programmers design software interfaces. They design an interface over the underlying implementation that exposes selected data and services. Interfaces take inputs, process them, and return outputs. Now, this is a generalization in one programming language called C++, but that's okay because we're aiming for a high-level conceptual understanding. So what you should see on the left in the implementation of whatever this code is that it's lengthier and seemingly more complex because it's the whole shebang. The interface on the right that is designed and exposed to developers instead essentially boils down the implementation to something more concise and puts boundaries around what can be done to the software and the data when calling upon the interface. Once I understood this view of a software interface, it finally started to click for me, a non-software developer who's never built an app. By choosing to make data and resources available and accessible through an interface, programmers can make coding an application more efficient and easier for themselves. They can choose what they want to share and make available for use in other systems that opens up the possibility for integrations. And because the interface exists as a middleman between the keys to the car, i.e. the backend shebang, it adds a layer of security to all that data. They can always add additional security parameters like authentication to make accessing that data even more secure. If we think about who uses an API, both human and machine, it should be clearer for you now how a software interface works. Software, in this day and age, does not yet write itself. In essence, software programmers write the source code of an application and design an API over that source code. The API is used by other programmers who continue to develop that software, or by programmers wanting to build on it or access data from within that app to use it in another. The API saves programmers time and makes them more efficient in their code. The API becomes a machine-readable interface for software to talk to other software without needing to know its whole life story, i.e. the bedrock code base. And finally, we end users unwittingly use APIs behind every click, tap, and swipe through the graphical user interfaces that we use to communicate with apps. And that's it for this first part in our series on the fundamentals of APIs and software interfaces. Thank you so much to all of my sources, which are included in the video notes. And coming up next, we'll cover remote APIs working over the internet to connect systems and data. We will recap how the web works if this is something you haven't thought about in a while so that it all makes sense. And you'll start to see remote web-based APIs everywhere. So I will see you there. Thanks.